All right, so here's 8.2, reflections. So in the previous video, translations are just sliding the figures on the plane. Reflection, I want you to think as a flip, okay? When you stand in front of a mirror, you see a flip image of yourself, okay? So you're flipping things over the line of reflection, okay? Everything has a line of reflection. I like to draw this little picture for my kids roughly because I am not a... So if you have a boat on the water and you have the water itself, and you will see a reflection of that boat, okay? Roughly a reflection of that boat, and that's what a reflection is. You see a flip image of that original image, and then there's a line of reflection, okay? Water is not the best example for me to use because it distorts the image a little bit, and in mathematics we do not distort the image stays the same shape and the same size. But I want to point out that there's that line of reflection, and things are equidistant, okay? So the tip of the boat is the same distance to the line of reflection as it would be the tip of the reflection, okay? Mathematically, yes. In water, no, because water distorts the frame, the picture, okay? But we're talking about equidistant. Everything will be the same distance from the boat to the water as it would be from the reflection to the water. Mathematically, it's true, but here it's not, okay? But we're talking about equidistant. Things are the same distance, okay? In mathematics, in a Cartesian plane, it is 100% true, okay? Not in the water, but I like, because the students do see that connection of reflection is just a flip of the image, and it makes a little bit of sense to them. So that's what we're going to be doing. Reflections is a flip. There is a line of reflection we need to identify. That is the first thing I identify when I am doing a reflection. I first find the line of reflection because I know that the image and the pre-image are equidistant from that line of reflection. That's a very important idea of equidistance from the line of reflection. Let's do a few of your homework here so we understand what they're asking. I like to identify the line of reflection. I'm trying to look for a highlighter here. Found one, okay? So line of reflection is very important. Let's look through here. It says reflection across the y equals -2. You need to make a note to yourself. I'm going to do it right here on the top of my page. Anytime I have y equals a constant, a number, any number, -2, 2, 5, 3, -10, doesn't matter what number that is, we call it a constant. If I have a y equals a constant, that line is always going to be a horizontal line. If I have x equals a constant, doesn't matter what that constant is. It could be the number 3, -3, 10, -5, does not matter. If it is x equals a number, that is always going to be a vertical line. So put that there to remind yourself of what we're talking about. Okay, so here it says, create a reflection of this image across the y equals -2 line. So here's y, the y-axis. Here's -1 on the y-axis. Here's -2 on the y-axis. I want to make a line right here that is going to be my line of reflection. Okay, y equals -2 is my line of reflection. I'm going to highlight it a little bit so maybe you can see a little bit better. There we go. That is my line of reflection. All of the points are going to be equidistant from my line of reflection. So Q, the point Q, it is up 2 units from the line of reflection. I'm going to reflect it over 2 units as well. So 1, 2. So Q is going to end up right here. We're going to label it Q prime. Now the point I is on the line of reflection. So I'm not going to reflect it over because it's already on the line of reflection. So this point stays the same. I'm going to label I prime right on the top of it. The point E is 1 unit away from the line of reflection. So I'm going to reflect only 1 unit away as well. and there goes my point E prime. The last one I need to do is this little point Z, which happen to be right here. So we are, let's see how far point Z is away from the line of reflection. 1, 2, 3. It is 3 units away from the line of reflection. So I'm going to go 1, 2, 3. And there is my Z prime. Now I can connect all the 4 points. The I to the E, I to the Q, E to the Z, and Z to the Q prime. They're all prime values. There we go. So there's the reflection. Okay? So always identify first, if you would take a little hint, always identify the line of reflection. Okay? That's a very important thing to do, because then you know exactly what the reflection, the distance to the line of reflection. All right? Reflect across the x-axis. So that's easy. You're going to be reflecting across the actual x-axis. Every point is going to be equidistant. I'm not going to do that one. I want to do a little bit harder one, which is number 3. The y equals negative x line. We talked about this line. This line is a negative slope diagonal. Okay, so maybe you need to make a note to yourself. We did put that in our notes in the class. So it's a negative slope downward, going down diagonal. If you see this as equation of a line y equals m, here's my slope, times x plus b, you see that b does not exist, so b is 0. Okay, the y-intercept is 0. And the slope is negative, so you should go down 1, run 1, down 1, run 1, and you keep doing that, down 1, run 1, and that is your line right there. Okay, so if I connect these dots, let me do it here the best of my ability. I want to make the line of reflection precisely. Okay, I want to make my line of reflection as precise as I possibly can, because I'm going to be counting distance from the line of reflection, and I want to do it right. Okay, so here we go. Let me go ahead, and just to make it even more important, let me highlight it. All right. We're going to be counting the distance, but diagonal things kind of, we saw this in class, that kind of, you run in a different direction. Like, I want you to, if you could imagine folding this paper right there over the line of reflection. And you can see that if I fold it over, that drawing would end up right here. Okay, it would not end up over here. It just doesn't make sense. It would end up over here if I had bent vertically, but I didn't. I bent it diagonally. If I was to paint this and then press it over, that painting job would appear right here. Okay, so I know I have an idea of where it's supposed to be. Visualize that this is going to come down here, and let's go ahead and count the distance. So I'm going to start with A. I moved 1, 2 to the left. Then I'm going to move 1, 2 down. Left means negative, down means negative. Here, the S, I'm going to move 1, 2, 3, 4, 5, 6 to the left, which is a negative direction. So I need to go 1, 2, 3, 4, 5, 6 down, which is also a negative direction. So this is my S prime, this is my A prime. The point T, I'm moving 1, 2, 3 to the left, which is a negative direction. Then I need to move 1, 2, 3 down, which is also a negative direction. And there's my T prime. The point J, I moved 1 to the left. Left is negative. Then I'm moving 1 down, because down is also a negative direction. And there's my J prime. Connect the dots. And there you have the precise image of this pre-image over here. If you fold it, you should see that it goes right over it. See? You should see that your drawing should go right over the other, and is a perfect reflection. Well, mine is not that beautiful and perfect, but it's all right. All right, there you go. Okay? So try to visualize that. If you had patty paper, which I should be providing for you soon, you would see this better. A lot of the students had a hard time with number 4. Okay, so I'll do number 4 for you, but let me help you with at least identifying the line of reflection. The reflection across the x equals -3. Remember the notes, I put it right here on the top? X equals a number is a vertical line. Let's find -3 on the x-axis. So here's the x-axis. Let's go to -1, -2, -3. So it would be this vertical line right here. Let's make it a big deal about it right there. Ka-ching. There we go. Let me highlight it so you see. That's my line of reflection right there. So if I went 1 unit to the left, I'm going to do 1 unit to the left as well. And so you can see the reflection, okay? So if I went 1, 2 units to the right, I'll go 1, 2 units to the right. And that will be a reflection of this, okay? I'm going to help you with one more, then I'll go back to number 4. Reflection across the y equals x line. So think of this at y equals mx plus b. B is the y-intercept. We don't see it here, okay? There is no y-intercept. That must be 0. So there we go. 0 is the y-intercept. The slope is an invisible number 1 in front of it. So I'm going to go up 1, run 1, up 1, run 1, up 1, run 1, and I'm going to do this so I can make this diagonal line. Connect the dots very nicely. You want precise line of reflection so you can count the distance. And there you go. Well, that wasn't perfect, but there we go. Okay, so do it as perfect as possible. Now, especially diagonals. Diagonals are kind of hard. I want you to imagine you folding your diagonal line right there. You know that just visualizing it before you even do anything, this should flip it over here. The H should come over here. The L should come over here. Okay, so you know that this reflection should end up over here. It does not make sense for you to put it up here somewhere. Okay, so count the distance from L all the way you went to the right. 1, 2 to the right, then come 1, 2 down here. Okay, so you know you're supposed to go in that direction. All right, so let's go ahead to number 4, which is the students had a hard time with it. Reflection across the y equals -1. So the y-axis, I need to find -1. It's right here. And then let's draw our line of reflection. The line of reflection is right there. Y equals -1 is a horizontal line. Okay? Let me highlight it. Right there to make it nice and pretty. That's our line of reflection. So let's reflect to the opposite side. Okay, the I over here, I need to reflect it down here. The B, I need to reflect it over up there. So we need to just jump over, okay? The I, let's count how far it is from the line of reflection. 1, 2, 3 units. So we're going to count 3 units down. 1, 2, 3. The I prime is going to end up here. Let's count the B. The B was 1, 2. So 1, 2. The B ends up right here, B prime. The L is only 1 unit away, so I'm only going to go 1 unit away, and there's my L prime. And the W is 1, 2, 3, 4. Then I'm going to go 1, 2, 3, 4. And there is the W prime. So let's just connect the dots. And right there, and right there. Okay? So that is the reflection that happens to be right on the top of the other, but that is the correct reflection for the original image. Okay? So I hope you get an idea of how to do reflections. First, find your line of reflection. The most confusing ones are the diagonals, because some silly things happened. This is a negative diagonal. This is a positive slope diagonal. So it's a pattern that you need to see what happens. Okay? All right. So now, not only I am going to do reflections, but I'm also going to figure out how the reflection happens. It says, write a rule out in words to describe the transformation. So not in coordinate notation. They just want in words. Okay? What happened? Reflected over what? Okay? So take a look at this image. To me, I like to make connections. This looks very similar to what we just did over here, okay? We did something on the top of something. So make a connection, guys. All these worksheets, whatever you see here on one side, there's a connection to the next page, okay? That's just how we work. All right, so it looks like it's an image on the top of the image. Let's find something that is equidistant. I look at J and J prime, V and V prime. Okay, let's find what is the right in between them. J and J prime is the easiest. It looks like if you move one unit, you hit this line over here, and if you move one unit from J, you also hit this line over here. Let's check if it's true for point K and K prime. So K, if I move 1, 2, 3 units, I hit this line over here, and if I come from K prime, 1, 2, 3 units, I also hit this line. So I immediately found my line of reflection, which is right here. Just pick one point and find something that is precisely in between, equidistant, same distance. This is a horizontal line, so it's the y equals. That let's find out how much. 0, 1, 2, that's the y equals 2 line. So it was a reflection over y equals 2 line. Okay? All right, let's do number 10. Let's do number 10. Let's pick 2 points and let's find right in between them. K and K prime is right in front of me, so I'm going to do that. So it looks like we go 1, 2, find a line right there. 1, 2, yep, that worked. And I'm pretty sure if you check for P, it will work too. P is 1 unit away from this line. P prime is 1 unit away. And if you check for R prime, R prime is 1 unit away. R is 1 unit away. So it worked. It is a vertical line, so it must be a x equals line. And you just have to find out what is it. Here's 0, 1, 2, 3. X equals -3. So this is a reflection over the x equals -3 line. All right? So just use the idea of this magic word, which is called equidistant. Okay? Reflections are equidistant from a line of reflection. All right, and let's do number 10. So you can see here. It looks like point P's. Let's go to the point P and P prime. Looks like if I go 1 over here, I hit the middle between P and P prime. It happens to be the y-axis. Okay, that's all I have to check. If you want to check for U and U prime, 1, 2, 1, 2, it works. Okay, so it's over the y-axis. Very simple. Okay, take a look over here. Something that was here, diagonally move over here. Very interesting. I bet you'll find an example in the previous page. Take a look at this one. You were up here, reflected down here. You jumped over some important line over here. So you should be able to see the line of reflection. Number 8, it kind of like got stuck in between each other. Take a look at point T, and point V is right on the top of each other. So it looks like there's something going on here right as a diagonal. Okay? So I gave away all of the answers here, so you can see that finding the line of reflection is very important, not only to help you graph it, but to help you determine the actual reflection, what happened. I hope that helps. You guys are the best. Keep plugging along. Let me know if you have any questions.